So hello friends, in this video we are going to discuss about plane of symmetry, that is a part of group theory. The plane of symmetry is represented by sigma. Sigma is the symbol of plane of symmetry. It is an imaginary plane present in the molecule which bisect the molecule into two halves, and those are mirror images of each other. If reflection is occurred through this plane and equivalent orientation of the molecule is obtained, then this is known as plane of symmetry. What does it say? It says that it is an imaginary plane. For example, this is the H2O molecule, this is oxygen, this is hydrogen, this is hydrogen. Okay, and suppose this is the plane. This is this rectangular shape represents a plane. When it bisect, this molecule, then it molecule look like this. This is oxygen, this is hydrogen, and this is hydrogen. Okay, so when this plane bisect this molecule, it will look like this H. This is the half of oxygen atom, this is half oxygen atom, and this is S. And now if we consider these two, these are the half parts of this total whole molecule of H2O. That's why we can consider this plane as a plane of symmetry, because it bisects this molecule into two halves and both are mirror images of each other. If we put a mirror, for example, here, then we will see that these are reflecting to each other, means these are mirror images of each other. So that's why this plane will be known as plane of symmetry. Okay, this plane of symmetry is a symmetry element and reflection is symmetry operation. So when we were talking about axis of symmetry, that time we consider rotation as a symmetry operation. But when we consider sigma means plane of symmetry, it means reflection. Reflection is the symmetry element. Okay, so it is denoted with sigma, that is the symbol. It is always represented by two axes. For example, this plane in this structure, just a minute, I let me erase this. Okay, so in this structure, this plane is along the z and y direction. Okay, or y axis. This is y and this is z. So always plane is represented by two coordinates or two axes. For example, xz, sigma yz, sigma xy. It means sigma xz is passing through x and z axis, or it touches x and z axis. Similarly, others. So if we talk about xz, sigma xz, it means this plane is passed through x and z direction, and or it touches x and z axis. For example, in H2, just upon B, we have understood already that how YZ plane is present in H2 molecule. So if we talk about YZ plane of symmetry in H2 molecule, so this plane passes through principal Z axis. After putting the plane, reflection is occurred or carried out, and then we get mirror image, that is equivalent orientation. And if second reflection is carried out, then the same structure means identity will be obtained. Therefore, this plane is known as plane of symmetry. Similarly, if we see, or for better understanding, with this diagram we can understand what is the plane XZ, YZ plane in H2 molecule. How does it work? So when after first reflection, this structure looks like this, and after second reflection, this structure looks like this. Here H and H days are written for understanding only. Both hydrogen are the same, but for the understanding, H and H days are represented. Okay, so after first reflection, H1 comes at the place of H, and H comes at the place of H dash. Okay, and after second rotation, the H dash again comes at its own place, and similarly H comes at its own place. So at the end, if we compare this structure, first structure and third structure, So we can see that both structure are exactly the same. Same means identity. So after two reflection in xz direction or through xz axis, we get identity. That's why this is the plane of symmetry. And why second structure is equivalent form of first structure. So in a molecule, there may be three kinds of plane of symmetry present in the molecule. So first one is vertical plane. As name says that vertical means it should be vertical in the molecule. It should be passed through vertical axis in the molecule. And it is denoted with sigma v. V means vertical, sigma means plane of symmetry. This is passed through principal axis and it vertical or parallel to it, and it gives equivalent orientation of the molecule through reflection as mentioned. So this is the vertical plane. It is passed through principal axis. It is always perpendicular, not perpendicular, parallel to principal axis. It will always be principal axis, parallel to principal axis. For example, if we consider H2O molecule and if we consider sigma xy plane, sigma xy plane, then x and y plane. So it no x and y plane is not a plane because it doesn't bisect the molecule. Okay, because this is the x, this is y, so it is yz plane. Okay, it is not xy, it is yz plane. Okay, so if this plane through reflection through this plane gives equivalent form, so that's why it is planar symmetry. And we know that there is z axis, c2 z axis is the principal axis in water molecules. That's why it's passed through z axis. Okay, so it is parallel to z axis, so that's why it is sigma v. Clear? And another plane, that is the xz plane. So xz plane is passed through x and z axis, and it is also parallel to C2Z axis. So that's why it is vertical plane. Okay, when reflection is carried out, sigma y through yz plane, hydrogen atoms are changed or shifted, but sigma xz is considered, then hydrogen remains unshifted. Suppose we are considering this plane x and z. So it will be bisected, and it will also be bisected. But these hydrogen will not be shifted. But in case of YZ plane, the hydrogen is shifted opposite to each other. So that's why, but both plane, sigma YZ and sigma XZ, both plane are vertical plane. Why? Because these are passing through z axis. That may be that means these are parallel to um, principal axis. That's why these are sigma v plane. Similarly, if we consider BF3 molecule or NH3 molecule, so in both the molecule there are three vertical planes are present. Okay, and each passes through BF or one NH bond respectively. So this is the BF3 molecule. So each passes through one BF in case of BF3 and one NH in case of NH3. So these are vertical plane because these are parallel to principal axis. Similarly, in penta trichloro phosphorus pentachloride, trigonal bipyramidal geometry, and tetracyanonickelide, it has square planar geometry. There are 3 and 4 planes. In case of PCl3, there are 3 vertical planes, and in case of this, there are 4 vertical planes are present, and these are parallel to principal axis. In case of PCl5, vertical plane is passed through P and Cl bond, and in case of tetracyanonickelate, the vertical plane is passed through nickel and cyanide bond. Okay, these plane are passed through principal or subsidiary axis and parallel to them. These are parallel to principal axis, so that's why these are vertical plane. So this is the illustration of PCl5, how vertical bonds are present, vertical planes are present in the PCl5, and how vertical planes are present in tetracyanonickelate. So in benzene molecule there are 6 sigma v passes through the principal axis and 1 subsidiary axis. For example, this is the benzene molecule. So if we consider benzene molecule, So this is the one vertical plane, this is second vertical, this is third vertical, this is the fourth vertical, fifth and sixth. So there are six vertical planes are present in the benzene molecule. Now, second symmetry, plane of symmetry is horizontal plane of symmetry. It is denoted with sigma h. Why do we call it horizontal? Because it is horizontal to horizon. It is passed horizontally in the molecule, and it is always perpendicular to principal axis. Suppose the principal axis, it will be always perpendicular to principal axis. So it can be represented like this, sigma h. H means horizontal, sigma means plane of symmetry. For example, in BF3, BF3 is a planar molecule, sp2 hybridization. So a horizontal plane is passed through all the atom, and it bisects all the atoms present in the BF3. Okay, so this is the horizontal plane. And in PCl5, there is a bond, planar bond like this. This is the axial bond, suppose. Because in case of PCl3, if you see the PCl5 molecule, so it is like this, Cl, Cl, and Cl. So these two are axial bond and these two are equatorial bond. Equatorial bond means these are in the plane. Okay, so a horizontal plane can be passed through this, which bisect the molecule in two halves. Two halves means this P will be bisected, this chlorine, and this chlorine, equatorial chlorine will be bisected, and one chlorine will be upper side and another chlorine will be lower side. So this is the horizontal plane. Similarly, if we talk about tetracyanonucleate or tetrachloroplatinate, so there is also a horizontal plane passed through whole C and nickel atom. Just see, this is nickel in center, and this is cyanide, this is cyanide, this is cyanide, and this is also cyanide. So a horizontal plane can be passed through all the molecule, which bisect this molecule into two halves, and both are mirror images of each other. That's why it has uh, sigma h, horizontal plane. Now sometimes it happens that there is no horizontal plane, there is no vertical plane, there is no any other plane. Okay, so there will be always a molecular plane. That we will discuss later. Now it is possible that there is no axis of symmetry. Suppose there is no axis of symmetry in the molecule, but plane of symmetry is present. Because abhi jo when just we talked about right now that we talked about vertical plane and horizontal plane. Vertical plane is always vertical plane here sigma v is always parallel to principal axis, and sigma h is always perpendicular to principal axis. Okay, so there is a correlation between principal axis and plane. But suppose there is absence of principal axis, then even then plane of symmetry may be present in the molecule. For example, POBrCl2, it doesn't have principal axis, it doesn't have principal axis. Okay, but it has molecular plane. Molecular plane means it has a plane which bisect the molecule like this. So when principal axis is not present but plane of symmetry is present, then and then only that plane will be known as molecular plane. Molecular plane. So this is the thing which we have to understand. Now come to the third one. Third one is dihedral symmetrical plane, and it is also denoted with sigma d. D means dihedral, sigma is plane of symmetry. So this is very similar. It is similar to vertical plane. Okay, it is similar to vertical plane. But when we will say it is sigma d, or when we will say it is sigma v, so for that purpose we need to use a trick. If in a molecule sigma h is present, if in a molecule sigma, just remember this thing, in a molecule suppose sigma h is present, then and then only sigma v will be sigma d. Sorry, sigma v will be sigma v only. Okay, and when horizontal plane is absent, when horizontal plane is absent, then sigma v will be sigma d. So that thing you have to remember. Sometimes in some books it is also written that suppose there are four sigma v. So two will be sigma v and two will be sigma d. But you need to remember this trick that if horizontal plane is present, then sigma v will be sigma v. And if horizontal plane is absent, then sigma v will be sigma d only. So when a molecular horizontal plane is present, then vertical plane will be vertical plane. But if horizontal plane is not present in the molecule, then vertical plane will be called as dihedral plane. So that thing you have to remember. If principal axis is Cn, just these are very important things. It will save your time. If principal axis is Cn, then either zero number of sigma v will be present or n number of sigma v will be present. So what does it mean? It means that suppose there is any molecule, and if we are able to see any one of sigma v, then we don't need to go to find out every sigma v, each and every sigma v. Just use this trick. If sigma v is present, then it will be n number of sigma v. If sigma v is not present, then it will be 0 sigma v. So for example, C3 is the principal axis, then 0 number of sigma v will be present or 3 sigma v will be present. For example, in H2O, there is C2 is principal axis and vertical plane is present. That's why there are 2 sigma v. And in case of BF3, the principal axis is C3, and because there is a sigma v present, that's why there are total number of sigma v are 3. In PCl4, total number of sigma v are 4. Why? Because directly we can write that because the principal axis is C4. So directly we can use the trick and we can tell about the numbers of sigma v. So 4 number CV, C4, that's a 4 number of sigma v present. But condition is what? Condition is one plane should be there, sigma v. That you have to find out whether one plane is present or not. If one plane is present, then n number of sigma v will be present. Similarly, in benzene, if sigma v is present, then 6 number of sigma v will be present. Now, this is a very important thing that sigma v can be more than one. Sigma v may be more than one, but horizontal plane will be always one. So sigma h will always be one only in any molecule, but sigma v may be more than one. More than one. So that thing you have to remember. So it's all about plane of symmetry. So there are quick revision. There are three kind of plane of symmetry: vertical plane, horizontal plane, and dihedral plane. Vertical plane, this is a parallel to principal axis. Horizontal plane, that is perpendicular to principal axis. And dihedral plane, if sigma h is present, then sigma v will be sigma v, and if sigma h is absent, then sigma v will be sigma d. So it is all about plane of symmetry.